Hey classes, welcome back. We're taking the show on the road. That's the field hat that's on today. So let's go walk around the room. And yeah, what it lacks in production value, hopefully it makes up for in content. This is Truckee, California right now. We're going to get to this in just a little bit. We'll get to this at the end when we show the water content that's building up in our Sierra Nevada. This water will later on be your drinking supply. Actually, the stuff here in Truckee will go down towards Reno, but the stuff at the summit will come down, fill our reservoirs, and hopefully put an end to our drought. All right, the other day we had what's on the board here, about 5 stations to go visit. I love doing things with the stations because it's a little bit like a mini exploratorium when we set up around the room. The first one over here, and remember weeks 18 and 19 were meant to be a little bit of a review. We're trying to review where we've been and where we're going over the last 18 weeks. Remember, we're about halfway through the school year right now. And when we saw this station, not only was it meant to review a little bit about the rings, the tree rings, how each ring represents a year of growth, but also when you think about the tie-in here with the beginning of the school year, when we're doing the earth sciences, why Earth is a perfect place for life. You've got our moon stabilized in our orbit, our Earth tilted at 23.5 degrees with respect to our sun as it orbits the sun once per year. And those tree rings, we wouldn't have seasons, we wouldn't have seasonal growth rings were it not for having seasons. Of course, this is winter right now. We just passed the solstice. We're headed for the equinox. And those rings represent the seasons on our planet because of our tilt with respect to the sun. So that was a little bit of a review right there. We'll be getting into more detail as we do plants and fungus coming up on the different tissues that you see here with the trees. So that was station number 1. Station number 2, we're kind of big on Venn diagrams this week. So let me click on that. Yes, it's a moldy bagel. If you check out this particular bagel that I put a little bit of water in the bag, I put it in a dark spot. I used a bagel that did not have preservatives in it because if you have preservatives, they don't mold quite as well when you use them in class. The Venn diagram here was meant to be what are the similarities, what are the differences between the fungus and plants. And when you look at fungus, a lot of people say, well, that's growing like a plant. But remember, this is actually, in terms of how it's getting its food, more similar to us than it is to a plant. This is heterotrophic, the fungus I'm talking about, of course, not the bagel. But if it's heterotrophic, it's literally eating the bagel. It's secreting an enzyme through its hyphae that digest the sugars that it's coming across in that bagel. And when you see something, yeah, it looks somewhat plant-like, so it's similar to a plant in terms of the roots and the hyphae have similar structures, but in terms of function, it's very, very similar to us. We are heterotrophs, fungi are heterotrophs, and you're looking at a good place to talk about the similarities between plants and fungus. Remember also, however, fungus put out mushrooms. They put out fruiting bodies. Not all of them have mushrooms, but they put out spores. They do reproduce somewhat similar to plants do. Fungus put out spores, where plants put out seeds. And seed plants, as we discussed in class today, the dominant form of plants on Earth right now. This right here was just getting students to think a little bit in terms of when we did our Earth science, the layers of Earth represented by different density layers. Here we have different density layers. We saw this particular graduated cylinder earlier in the year. It is separated by density. That's what's the same about this graduated cylinder and our planet. What was different, of course, is that our Earth is kept hot internally, mainly through the radioactive decay of elements and also from leftover heat from its formation. And we have convection currents continually circulating the layers from the hot core up through the mantle. That's what drives plate tectonics. Plate tectonics is what drives the rock cycle. And the rock cycle, bringing us over here, again on my rolling cart, we've got this piece of coal right here, technically a fossil fuel, but you're not going to find any fossils in this. It's a metamorphic rock. This particular one came from my grandfather's backyard back in West Virginia. And if you're looking at the fossil fuel right here, when you really think about the way we get more than half of our energy in this world in terms of the industrialized world, we're still like cavemen. We're still taking, dig up rock, burn it, get heat. This is where we get most of our fuel. This is coal. Remember, oil and natural gas, also fossil fuels right here. but you're not going to find any fossils in that. It's metamorphic rock. This is made from the remains of plant material, somewhere around 300 million years old during the Carboniferous period. These other particular types here are partly for comparing and contrasting, and we'll get to the Sierra that's up on the front board there too. This is obsidian, volcanic glass, chemically very, very similar, almost the same as granite. And this is basalt, also extruded volcanic material. This particular piece came from 7,700 feet up in the Sierra Nevada, as a matter of fact. And you're not going to find any fossils in those because the fossils have all been, if there were any, baked out of them. That's old volcanic rock. Down there, I won't wheel the cart all the way down there, but we had some seeds as examples. We used to do an experiment where we would actually burn peanuts, a seed, one, to get the calories, and two, we would take them apart in class to check out the small plant that's developing and the food source that they have. As they get growing, they've got their own food source. That's what's wonderful about seed plants. That's why they were so successful once they were evolved on land. There still are plants that are non-seed, seedless plants, but seed plants have really taken over. And then the other thing we had on the back station here, station number 5, was a whale vertebrate. So we saw that last week. Going back to the front of the room, we had a picture of Truckee up here because we're talking a little bit about the water cycle, a little bit about the hills around here, which of course are the Sierra Nevada, the granite hills of the Sierra, the granite mountains of the Sierra. Interestingly enough, in this area they have a lot of basalt as well because it was extruded, kind of dammed up Lake Tahoe. Most of what you see right here, this snow here, is going to go off down the Truckee River. It's going to supply places like Reno and Nevada with their water. The stuff just barely on the other side of the Sierra Crest there will go our direction and will fill up our reservoirs, giving us our water for the summertime, for drinking water, for irrigation. So killing this right here. This week we have, this is our key terms. Our key terms are up here. Again, a little bit heavy on the Venn diagrams. We had a little bit on the brain pod to define a moss, define a liverwort. And remember, our key terms and our notes, especially as we go from halfway in the year here forward, they're a little bit more interactive. It's not just, hey, write this down, this will be up on a test, and this is a good example of it. Instead, students are required, students are expected to fill in the blanks on their notes right here to make sure that they're getting the things in class interactively as we go. It's not just a lot of lecturing, which is why I like going through the stations. It gets us out of our seats a little bit. Definitely we will have our open note quiz online Wednesday through Friday. It'll be open on Wednesday all the way through Friday. There is not another assignment besides the key terms right now because possibly our scientist guest speakers will reschedule. Remember, we lost a day last week because of the storm. We might get that back this week. If not this week, it'll be next week. Regardless, if they come this week, that'll be our second grade this week. If they don't, if they're not able to reschedule for this week, we're going to be doing a lab on Thursday or Friday. And then finally, when you saw what was on the notes over here, the last thing, it was going through those stations that you just saw. The stations that we had around the room, we had the Venn diagram comparing, contrasting the plants, the fungus. We should know the things that are the same about them, the things that are different about them. Obviously, heterotrophic and autotrophic being one of the main things that we're checking out. This right here went along with the tree rings, a little bit of review on the tilt of our planet, why we have our seasons. And let's see here, we also had the layers of the Earth here, the density layers. That's how the Earth is separated from this very, very dense iron nickel core all the way to the lighter stuff that floats up here on the surface. And the convection currents, we ended up with a very brief clip, 10 minutes or so, on Bill Nye the Science Guy talking specifically about flowers, and flowers being the reproductive parts of plants. Well, we're kind of done reviewing here through weeks 18 and 19. When we go forward into weeks 20, 21, 22, we're going to learn all about the parts of plants, the parts of fungus, and then we go into human body systems after that. So that was a quick recap of where we've been and where we're going this week. Have yourself a great Monday, and I'll see you online. Bye-bye.